You guys have been able to announce just at the Space Access Conference a very new and exciting product that could possibly be a game changer in the aerospace industry. Yeah. Can you tell us a little bit about what it is that you guys are doing and how you were able to get to the point where you are?
Yes, I work with a company called Viaduct International. We're what you would call a business accelerator. So we find products or companies that are working on something really cool, but they just need that little push to get out into the public to be known. And we found a company called ZēneCorp, which has some really cool carbon fiber composite patents, and they really want to expand it, but they didn't know what the next step was. So we were brought in, and we analyzed it and said, yep, there's a winner here, and the rest is history, as they say. My first point of being brought on board was that, here, look at this technology, tell us will it work, and then go and present it into the aerospace industry and see what they think. And so that's what I'm here to do, and we think we got a winner.
So tell us what makes the difference between the composite work that they're doing versus all the other composites out there?
Well, with carbon fiber composite, there's usually 3 ways that you can work on it. The traditional way is to do what's called a layup, where you have like a foam model, the actual product done up in foam, CNC milled, and then you lay your carbon fiber over the top of it. Other methodology is to use vacuum form, where you lay out your carbon fiber, you put your resin into it, and you apply a vacuum, you pull all the excess out, and you make a part. The third methodology is called air injection, and that's where you have a large mold, you have air nozzles that go into it, you put it all together, you close it, you inject air, you raise the temperature, and you create a part that way. Each of these methodologies has different problems. Foam layup, you can end up with what are called voids or gaps in the material where it didn't bond to the foam, and that's a potential structural weakness. Vacuum forming is messy, and you cannot make extremely complicated parts with it. Okay. Air injection mold process is pretty straightforward, but at the end of the process you end up with these extra parts, the air nozzles that were connected to kind of inflate the mold or the product inside the mold. And you can't always get air into all of the pieces that you need. So they can be complex but not incredibly complex. Okay. The difference with our system is that it's a solid core composite. We use a microbead structure in between the layers, so that we lay it up just like you're going to do in an air injection mold process, but instead of having nozzles, we apply the microbead material in the layers with the carbon fiber. Once we've done that, you close the mold, you heat it to a nominal temperature. Instead of going to like 600 degrees Celsius, we can do it at 200 degrees Celsius. And literally, if you wanted to, you could put this in an oven at home and bake your own parts. The microbeads, they expand at a temperature just below the cure point. So they inflate, they push all of the material up against the side walls of the mold and hold it there until it reaches cure state, which is about 20-30 minutes. Okay, you cool the mold down, open the mold, and ta-da, you have a finished part. And it can be of any complexity that you want. That's the beauty of it. You can put parts within parts, you can put channels for wiring, have all of that built, lay it all in the mold, close the mold, push the button, heat it up. When the timer's done, you've got a part that can be incredibly complex all in one piece. Right? That in itself is phenomenal. But by using the solid core composite, we can reduce the thickness of carbon fiber that's used and therefore make the part lighter, yet at the same time make it stronger. We're looking at, in some cases, as much as 1/3 less weight and twice the tensile strength. And that's some pretty impressive tech.
Absolutely. So what sort of possibilities could there be out there to do kind of large-scale manufacturing, or at least large parts that could be done with this sort of method?
Oh, the beauty of the method is it lends itself, one, to mass manufacture. So if you have small, medium parts, you could actually crank them out, just like you would do a regular injection molded plastic part, and it's fairly quick. It's not days of layup with carbon fiber. But for larger pieces, you could, in theory, lay up your entire wing of an aircraft with all the components, the spars, everything ready to go, your wire channels, and boom, out pops a finished wing. And so you can do incredibly complicated things. One example we were talking about is you could mold an entire rocket in one pass, complete with an avionics bay. All right, then you can just apply a fluid to remove the foam from the avionics bay and go fly your rocket. And it's literally, it's all one piece instead of multiple pieces that have to be glued or bonded or assembled, which those are always stress points, and you typically have failure at those bonds. And those bonds don't exist with our technique.